In Form 1, Topic 1, matter is defined as anything that occupies space and has mass. These substances do change and they have their states that change constantly depending on the energy that is applied to them. States of matter are three. We have solid, liquid, and gas. This matter is normally made up of very small particles called atoms. Atoms are very small and tiny. They cannot be seen with the naked eye. When atoms combine, they form molecules. When molecules combine, they form matter. So these particular particles do move. In solids, they vibrate. In liquids and gases, they move because they are widely spaced. And they move because of energy that is exhibited by these particles. And that energy is called kinetic energy. So this energy fuels the motion of these particles, and that gives rise to a certain theory of matter called kinetic theory. And this particular theory states that matter is made up of small particles, and these particular particles are normally in constant and continuous motion. If solids are to change from solid to gas, there is normally need to supply energy. So remember, we have said that particles in solids have fixed patterns. They are fixed in positions, and the only way they can move is through vibrating. If you hit a piece of metal, you'll be able to notice those vibrations. It's because of the ability of these particles to move. They do not move entirely, they vibrate because they are in fixed positions. So the change of state from solid to liquid happens during some temperatures called melting point, and the temperature at which solid changes to liquid is called melting point. So when you're supplying heat to ice and then the ice starts to melt, at that particular temperature it's melting. That's what we call melting point. And at that temperature, the temperatures do not increase. Remember, when you are heating, you are increasing the kinetic energy. When you increase the kinetic energy, the force that holds the particles together to make a solid becomes weak, and you form a state or a substance that is able to flow, made up of matter that can move continuously. The same liquid that has been formed previously may change to a gas, and the temperature at which liquid changes to gas is called boiling point. The boiling point of water is 100 degrees Celsius, and this particular temperature is only for pure water. And also it must happen at 0 atmospheric pressure. It must happen near the coast. It must happen near the sea level. If you add substances like sugar or salt to water, that water will not boil at 100. It will boil at a higher temperature. In the same way, if you have your ice that contained sugar or salt or any other substance, making it impure, it will not melt at 0. And that is one of the effects that we have. So during boiling point, temperature will always remain constant. So according to that, matter has three states. We have solid, liquid, and gas, and this can be explained using the situation where you have ice changing to water and changing to steam. It is possible to reverse the process. From steam you form water, you form ice, it's possible to reverse the process. There are three types of arrows in chemistry. The first kind of arrow is like this one placed at this point. It is a forward arrow showing that you have a certain product from a certain substance. That substance from another product. So the arrow shows a product on this side and what we call a reactant on this side. There is another kind of arrow that goes backward. And this backward arrow shows that the reaction or the process can be reversed. For example, if you have ice and you show it changing to water, you can show that water will change back to ice using half arrows. So to show that a process is reversible, you use half arrows. The half arrow will show the forward reaction and the reverse reaction. So it is possible to reverse them. And steam changing to water, we call that condensation. Water condenses. And changing from water to ice, we call it freezing. This information can be represented in form of a graph. And in form of a graph, we call it the heating curve. We can be able to show how it changes in a graph. And in this graph, we normally have our axis. We have this vertical axis and we also have a horizontal axis. On the vertical axis shown by this going from this particular point upward, we normally have our temperature plotted against it. And then we shall also have another axis that shows time. How much time do you need to heat water to start boiling? So you have time, and it normally starts at, in some substances it may start at 0, in some others it is not a must to start at 0. So it starts at this particular point. You can say I'll start heating water from 10 a.m. and then I'll be able to wait and see at what time will it have changed to gas. We do have the example of ice. You have your ice, you are warming it. What happens is, as you are warming ice, temperature increases from this particular point to this particular point. And as ice absorbs that heat energy that you are supplying to it, definitely it will start to melt, and that's what we called the melting point. So at melting point, the temperature has remained constant. You can see that at this particular point it's flat. It remains constant until all ice has melted, because the energy that was absorbed at this particular point is being used to weaken the force of attraction of that ice until all of it melts. The water, once it is formed, it will also absorb heat energy, and this is shown by the fact that temperature at this particular point is increasing upward until this particular point. So the temperature increases, and once the temperature is sufficient enough, we shall have our water changing into a gas. It will start boiling and changes to a gas, and this is what we called our boiling point. At this particular point, you can see again the temperature remains constant, shown by the fact that the curve remains flat. This is called the heating curve. The heating curve shows how matter changes from solid to liquid and then to a gas. Remember not to forget terms like kinetic energy, melting point, boiling point, freezing, and even condensation. That's the end of this presentation.